Hello friends, in today's class we are going to see about the CPU performance and power consumption. The first one is pipelining. So ARM usually got three stages of pipelining. One is fetch, decode and execute. During the fetch operation, the instruction is fetched from the memory. During the decoding operation, the instruction opcode and operands are decoded to determine what function is to perform. And the final one is execute. The decoder instruction is execute. So this is the pipeline instruction of the execution of the ARM instruction. Here there are the three instructions. One is add and subtract and compare. So during the addition operation, the pipelining instruction executed in horizontal manner, that is fetch, decode and execution of addition operation. During the second set of instruction, the pipelining operation has been started. That is, the fetching of the subtraction instruction start the decoding of adding instruction. So simultaneously it will happen on each other. So during the execution of addition instruction, the decoding of subtraction instruction has started, then following by execution instruction. Similarly for the compare instruction. So in this way, the pipelined operation of ARM processor is executed. Then the pipeline stalls are installed based on the instruction. Here we have used the LDMIA instruction, that is multiple load instruction increment after. Load multiple instruction increment after or not. So this instruction takes two execution cycle for R2 execution and R3 execution. So the second instruction will do, that is the subtract instruction. It starts the fetching of the subtraction instruction during the decoding phase of the LDMIA instruction. But once the completion of execution of LDMIA instruction only, it can decode its instruction. So it will wait till the execution phase completed in the first instruction. So once after completion of the execution instruction, it will start the decoding of subtraction instruction. Then simultaneously it will execute the subtract instruction. So because of the one extra execution phase here in the first instruction, there is a pipeline stall in the subtraction instruction. So similarly for the compare instruction, here one stall is installed, because in this time period only the compare instruction should start the fetching instruction, but it delayed to the one set of instruction. So this is called pipelining. Then we are moving on to the control stalls. So here BNE, that is branch not equal. So if there is not equal, it has to branch. But this instruction is not decided until the third phase of execution, where it go. Where should it go? That control should go to some other address, that is FOO address. That instruction address is not predicted, or it is not checking the condition until the third phase of execution. During that time, the second instruction, which is next to BNE instruction, is started executed. It started executing its fetching and decoding operation. So once the first instruction find where it has to go, whether it has to take the branch or not, while it's deducting its address, already the subtract instruction fetching and decoding operation is completed. So what the CPU will do? The CPU will throw off these two instructions and it will start executing these subroutine, that is FOO is the subroutine, and it starts from the subroutine address of fetching and decoding and execution of addition. So this is nothing but the control stalls. Then coming to the caching. So we introduced the cache because they sustainably reduce the memory access time when the requested location is in the cache. However, the desired location is not always in the cache, often is called cache miss penalty. The amount of variation depends on several factors in the system architecture. but the catchy miss is often a several clock cycles slower than the catchy hit. The time required to access a memory location depends on whether the requested location is in the catchy or outside of the catchy. So if it is outside of the catchy, there should be a miss. There are several misses available. One is the compulsory miss and conflict miss and capacity miss. So this already we have seen in the memory management mechanism. So we will move on to the next topic, that is CPU power consumption. So the power consumption is in some situation as important as an execution time. So in this section, we study the characteristics of CPU that influences the power consumption and mechanism provided by the CPUs to control how much power they consume. So here, the complementary metal oxide semiconductor, that is CMOS circuitry, that is the basic source of the power consumption, that easily identify and briefly described below. So the first source of power consumption is power supply voltage. The dynamic power consumption of CMOS circuit is proportional to the square of the power supply voltage. So here the power reduction due to reducing the power supply voltage to the lowest level and provides the required performance. Add the parallel hardware and even further reduce the power supply while maintaining the required performance. A CMOS circuit uses most of its power when it is changing its output value. That is called capacitive toggling or toggling. This provides three ways to reduce the power consumption: reducing the speed at which the circuit operates and eliminating the unnecessary changes to the input of the CMOS circuit and eliminating the unnecessary glitches at the circuit output. Then coming to the leakage. Even when the CMOS circuit is not active, some charge leaks out of the circuit's node through the substrate. The only way to eliminate the leakage current is to remove the power supply. So completely disconnecting the power supply eliminates the power consumption, but usually it takes significant amount of time to reconnect the system to the power supply management. So as a result, we see the following power saving strategies used in CMOS CPUs. The first one is CPU can be used at reduced voltage level. For example, reducing the power supply from 1 volt to 0.9 volt causes the power consumption to drop by 1.2 volts. The CPU can operate at the lower clock frequency to reduce the power consumption. The CPU may internally disable the certain function unit that are not required for the current execution function. Then the CPU allows part of the CPU to be totally disconnected from the power supply to eliminate the leakage current. So these are some of the technique to use to reduce the power consumption in the CPU. Apart from this, there are two types of power management features provided by the CPU. One is the static power management, another one is dynamic power management. Thank you.